Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 572, subtree of another tree. We're given the roots of two binary trees and we need to return true if there's a subtree of the root with the same structure and node values of subroot, and false otherwise. So, subtree of a binary tree is a tree that consists of a node and tree and all of its node descendants, and the tree could also be considered as a subtree of itself. So in this example, we're given a tree and a subtree, and we can see the subtree fits into our tree, so we return true. In this case, we return false because although the first top part of the tree fits into our subtree fits into our tree, it should be recursive, so it should be all the subtrees as well should fit in. So we return false in this case. So let's hop into the code. Let's create our depth first search function. Let's call it root, and we'll set our base case. If not root, then we just return false. Okay. Then we want to say if so basically we need to compare the two roots. So we're going to say if subroot is equal to our root, then we can return true, and then we can say return DFS of, let's say, root.left or DFS of root.right. So, and I'll tell you why this won't work in just a second. So let's run the code and let's see why this doesn't work. Okay, so we passed one case but not the other, and why is that? It's because when we're using this equals operator on our trees, Python is checking if they're the same in terms of memory location, but not if they're the same in terms of if they're the same object in memory. But they could be identical, but then it's not comparing its structure. So it's not comparing its structure and its values. To be able to do that, we need to create a helper function. So it's going to be similar to our same tree solution that we did in another video, in a previous video. So for this helper function, we're going to take two trees in, and we're going to say if not s and not t, we're going to return true because both nodes are none. So they're both equal, technically, so we return true. If not s and or not t, so if maybe s is none but t isn't, or t is none and s isn't, then they're not both the same, so we return false. And then we say if s.val does not equal to t.val, they're not equal again, we return false. Otherwise, we return we can just return is same tree and s.left and t.left and s.right and t.right. So that's our is same tree help function written up. Now let's plug this in to where we were doing the equals comparison, and we'll pass the first tree s as root and second tree will be our subroot. Now let's run our code again. Okay, so let's submit our code. Let's make sure all the test cases are passed, and there we go. So we have an efficient solution which passes the Leetcode judge. So in terms of time complexity, well, it's going to be, we're doing this comparison for, we're calling this helper function for every node. So it's a bit of a brute force approach. So worst case scenario, we're looking at O of n times n time complexity. And space complexity, well, normally with DFS we get O of h, but we've got the heights of two trees in this case. So it's double the core stack. It's going to be O of h1 plus h2. So what that means is h1 is going to be the size of our root tree, and our subroot tree is going to be h2. So O of h1 plus h2. So I hope you guys found this video insightful and helpful, and I'll catch you very soon.